How many elements did the ancients believe in? 4. And the 4 elements were? Yes. Now, does that sound silly to you to think that everything's made up of fire or water? Are these guys dummies? It's just like, why would you think this is made up of fire and water? Well, this is why I encourage you, first think, perhaps they're not being literal. Just keep that in your mind. Now I'm going to ask you, of course there's a difference in number, but is there a difference in kind between our 119 elements in the periodic chart and their 4 elements? For example, there's clearly a difference in kind of what we're doing versus mythology. It's something different. By difference in kind, I mean we're doing something totally different. Do you think that when the ancients are talking about 4 elements, specifically the Presocratics, are they doing something entirely different than what we moderns are doing with modern science? Or is it just simply it's more refined in the numbers realm? Somebody go grab that guy. Mess up the audio. Don't tell him he's messing up the audio. Yes, sir. Or bring him in. I don't. Yeah, come play for us. So inconsiderate. Yeah. Well, better down the well, down in that tunnel right there. It sounds really nice. Don't believe me? It's really distracting, but think about it this way. What if we give kind of a rule of charity here? We won't think that they're dummies. By the way, we tend to think that way about people who pass primitives. Savages. They're so dumb. That we've advanced, we have technology, we have the internet. We must be smarter. Are we getting smarter? We're progressing. Progressing to where? Where are we going? Get me off this ride. I don't want to go. I didn't sign up for this. Yeah, we might be digressing. So let me give you an example of a really interesting thing that I watched a few years ago. They were trying to figure out, do you know what an obelisk is? Correct? The national monument in Washington, D.C. Egypt created an originally the obelisk, and it looks like something like that, right? It's got really, yeah, we've got hieroglyphics going up it and stuff like that. So they were trying to figure, just like the pyramids, well, how did these primitive savages build something like so spectacular? They're idiots. I call that type of reasoning, when people buy that, futurism. That just because we're moving in the future, we must be getting better and smarter. Well, that doesn't follow at all. You're going to have to get more evidence than that. You can't just, it's the future. What the hell are you talking about? The future. What is that thing? You've never heard of it. We tried to figure out how they were doing it. We have like, they have in the video, cranes trying to lift that up using our modern technology. It was like breaking the crane, falling apart, and our modern technology could barely do it. But they didn't have that. So how did they do it? The problem is, just like when I give riddles, often children get the riddles far quicker and easier than we do. And the reason why is that we're thinking about it too complicated. You've learned all these various things that the kids haven't, that you're trying, it's just making the matter much more complicated. And in science, we actually have something, a principle of parsimony, called Occam's razor. And Occam's razor says, don't make it more complicated. If you can answer what you're trying to explain using fewer things, that's to be preferred. Same with mathematics. Nobody wants a huge, long, like proof across the board when you could do the same thing just using a small. Why are you wasting your energy doing it? In fact, there's a sense of beauty and asceticism that comes about when you can do the same thing using far less moves. It looks beautiful versus somebody that's like trying to well, I've got to get the stove on. It's like, well, why are you doing that? I don't know. Just go turn the. That looks nicer when you just walk up and turn the stove on rather than doing that stupid dance that you're doing. That's the principle of parsimony, and it's preferred in science. Perhaps we moderns are too complicated. We make things too complicated. So you know what they figured out the solution was? A sandbox. They probably built a sandbox, which is very simple. And on this sandbox, it could have a ramp. And fill it with sand. And let's suppose there's some plugs here that you can pull out. Now you could take the obelisk up here, like that. Have ropes around it. And let's say down at the bottom you build a little pivot point. What happens if I start pulling the plugs out of the sandbox that I built? Okay, and as the sand starts to diminish, what's going to happen to the obelisk? It's going to start to fall down. You can guide that right into. Now, which method would you prefer? Spending $1 million on a crane that's probably going to break trying to lift that heavy obelisk, or build a sandbox and pull the sand out and some ropes? Who's more advanced? And yes, we didn't have to introduce aliens to explain that. Well, the aliens give them the end. It's like, okay, that's
good try.
Yeah. Now we're reverting back to mythology, right? This is called like God of the gaps. When you can't explain something, throw God in there or an alien. Where's my keys? I can't find them, honey. The aliens took them. That's the only thing that explains. Yeah, that's not doing philosophy or science. Yes.
I believe it will be the one.
Aliens. I don't know. Probably brains. Probably lots and lots of money and much more complications and manpower than a sandbox. So I bring that up because perhaps they're not primitive. Perhaps we're not progressing as far as we think that we are. We could do the same sort of thing. So just as kind of a rule of charity, we give them the benefit of the doubt and ask yourselves, what if they're not actually believing that it's literally made up of air? But again, if you're going to try to explain scientific principles, providing natural explanations for natural phenomena to a culture that only understands mythology, you might use poetic verbiage. Well, it's like there's some sort of principle there. We don't know what it is. We can't see it. Well, what is it like? Well, it's like air. What is air like? Light. What is earth like? Heavy, rigid, solid. Flat, unless it's a rock, a round rock. Water. Fluid. Viscous. What's viscosity? Yeah. Fire. What's fire like? Yeah. Now, if Earth tends to just float around, tends to go where? Directionally. Down. Then what does fire tend to do? So do you see what we're thinking about things in nature? And what you could do is name, well, whatever the principle is, it's something like air, or it's something like fire. Well, really, that's sort of what we're doing with the atomic elements. I don't think that when Einsteinium was named on the periodic chart that we really thought there was a bunch of Einsteins. It's like, well, you just actually get an electronic microscope, you might actually see there really are much. No, it's named after somebody, or it's named after some type of quality that you recognize somewhere else. So might it not be that they're doing the same sort of thing, but they've just started off doing science. So no, they don't have 119 elements in the periodic chart. They have 4. They don't have atomic weights. They haven't developed that. But the principle is the same. They're not saying, well, God's crying. That's why it's raining. They're saying, no, it's made up of elements. And the way the elements interact, so they're giving natural causes to the natural phenomena. And therefore, they're doing science. This is why it's the beginning of science. Now, if you had to match element out of the periodic chart to one of the 4 elements, what would you do? Let's start with Earth. What is this is straight up organic chemistry, guys. You didn't take your organic chemistry. That wasn't a prerequisite for the class. You said it. Carbon. Every organic substance is made up of the various combinations: carbon, hydrogen, oxygen. Sometimes you can have nitrogen, but it'll always include a combination of this. These 2 are gases, this is solid. And well, clearly water would be what? Air? Fire? Combusted oxygen? Fire is? Well, you have to burn. Yeah. Well, nice that you bring that up. So imagine I drive. I'm going to try to get you in the mindsets of how the Presocratics are thinking about this. Suppose a stupid picture I'm drawing is a log. I actually know how to draw. I'm just lazy. Yeah, I don't want to waste my time doing that. I believe I didn't even actually almost kind of leave. Do I have a red marker? Yes, I do. Nice one. So, let's suppose combusted O2 is fire. Now, what would any tree or log be made up of? Carbon. But if it was just carbon is diamonds, graphite, and pencils and stuff like that. How moist is that? Dry. Carbon is dry, earth. That tree's moist, isn't it? So it must have a principle of what? Right. So carbon and water. Or in other words, if you're Presocratic, earth and water. Now what happens when I burn this? What's going to happen to the water in there? It's going to evaporate. And what's going to be left after I evaporate it all? Ash, which is what? Carbon. I've taken the water out. And is the water, because why? I put heat into water. What happens when I heat water? It goes up, it evaporates. So, and air is simply, so hot air goes up until it does what? It cools. And when it cools, it turns. And actually you have hydrogen too. You have hydrogen and oxygen coming out of the. Well, isn't that interesting That's science. That's a basic form of science. Even, do you know who came up with the periodic chart? Starts with an N. Yes. It's great. Why am I even up here lecturing you? You already know the answer. Mendeleev, when he came up with his periodic chart, did he have all the elements? Yes, he discovered a pattern and he knew where to look to find the new elements. Exactly. Well, might we not say the same thing here, that they started with what they knew, with the anticipation that this would grow. So now you're starting to see that these guys are bright.